Hello again. Today we're going to be talking again about working with normal distributions, but we're going to kind of approach it from a slightly different angle from the way that we were doing it in the last video. Just give me 1 second, I'm just adjusting my microphone. I should do these things before I start. So yeah, we're going to approach it in a slightly different way this time. We're still working on review exercise 3.4. But now we're going to be on question 2. What we're trying to do is we're going to be determining the value of the standard normal variable z naught for the following probabilities. I'm going to try my best to give you some explanation around how to do this, or sorry, around some of the theory behind this as I go along, and so hopefully this will help out. So question A, or 2A, so this is, it says the probability that z is between z naught and 0 is equal to 0.3212. So what we're doing here is we're kind of working backwards. We have some number in existence, and we have some region on the standard normal curve, and we know that that region gives us a particular probability. But we want to work backwards to figure out which z naught would we have needed to set to find that probability on this table. So before we were looking at the columns and the rows and trying to find a probability. Now we're going to be looking at the probability and trying to find what our z naught value is. Okay, so let me just draw a picture to try to illustrate this. And again, it's always a smart idea to draw a picture to help you out with these problems. It's always easier when you can see it visually, or at least it helps me. So it's saying our variable is bigger than 0 and less than some number. So we know that z naught has to be bigger than 0 too, because it's bigger than other numbers that are bigger than 0. So z naught's going to live somewhere out here. We don't really know where, but I'm just going to kind of guesstimate. And there's no really reason I should have picked that far out either. It's just what I did. So that's the region we're trying to find, because here's 0, and we're saying that the variable itself ranges above 0 and less than z naught. So we're less than z naught, but we're bigger than 0. We're trying to find that probability. Well, because everything's based around the 0 when we're working with this stuff, this is kind of like the easiest kind of problem you can do in this this particular section, because we already know that this z naught is from 0 to z, or that the variable goes from 0 to z naught, which is exactly the setup that we have on the table. So this region's just like the region on the table, except of course I drew it differently. So we know, though, that the probability we're getting is 3212. So what we have to do is we have to look on this table and try to see if we can find 0.3212 on it, or something very, 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 very close. So I'm going to look. These are the zeros. We have some 0.1s. We have 0.2s. On down to the 0.3s. We want to find 3212. Oh, and right there. Okay, and so then we have to look at the z value that this corresponds to. 0.9 over here and 2 over here. So what this tells me is that z naught is equal to 0.92. Easy as that. Easy as that. So there's your answer. Maybe I'll start circling my answer just to point out when we're done, because sometimes it can, if you're not experienced with this stuff, it can be difficult sometimes to figure out when you're done or when to stop. So the idea here is, what it was saying was that we have some region on the graph, or that constitutes 32.12% of the entire curve. And we know that the region goes from 0 up to some number, and it says, well, what's that number? And by working backwards, we found out that z naught, the number that sort of delimits that, is 0.92. Now B. For B, it's saying the probability that negative z naught, or that z is between negative z naught, and z naught is equal to 0.9942. So just like with the last question, there's easier ones and there's harder ones, and so this one's going to be a slightly more challenging one, but we'll get through it. So what it's saying is z lives between positive z naught and negative z naught. So obviously negative z naught is going to live somewhere down here, and positive z naught is going to be up here, right? Because it's positive. If this is the 0, and everything beyond this must be positive, everything below that is going to have to be negative. And then, sure enough, because it's between positive z naught and negative z naught, we can just go ahead and shade everything in that region. Okay? All right, so now let's try to work backwards here. Now this one's a slightly trickier one, but conveniently, the distance from 0 to negative z naught and the distance from 0 to z naught should be equal. So we know that each of these, the probability in each of these regions, for instance, the probability that 0 is less than z is less than z naught, this should be equal to this thing divided by 2. 9942 divided by 2, right? And that's just because, again, if this whole thing is 0.9942, the probability of that whole region is 0.9942, then, and both halves are the same, then 1/2 should be the total probability divided by 2. So let's just get out our calculator and try to figure that out. 0.9942 divided by 2. So I get that this is equal to 0.4971. And the reason I'm focusing on 1/2 is because, the reason I did this is because everything around this table, as you're coming to see, is based around 0 up to some number. So if I'm going to ever have a hope of taking a probability and guessing a z naught, I'm going to have it based around going from 0 up to z naught and not, this wide looking thing. So this region in here is just, I'm just looking for my other pen here to try to illustrate that. This right here is just this little region in here. Oh, maybe I'll make a cross just to highlight it. Okay, so now actually we're almost done, because in this situation all we had to do was find this number on the chart and look up the z naught value. Well, same thing here too. Where's 4971? 4971. Sure enough, we already have it underlined because we used it in the last video. 2.7 and 6. So it's 2.76. Or is that right? Let me just double check. Sometimes my eyes can deceive me. 2.76. Okay. So z naught is equal to 2.76. And notice we didn't even really have to use the negative at all. It was enough to know that everything was symmetric, and then just focus on the positive, because now that we know the positive, the negative was the exact same number. So there's no problem there. C. All right, so this is the probability that that z is less than 1 and z naught. This is equal to 0.0686 or 6.86%. So we're going to draw that picture again. We're always drawing our picture, and we're going to make the chart. So 1 we know has to be bigger than 0. So 1's going to live somewhere up here, 1. And then z naught, we know that z naught's bigger than z, and z is bigger than 1. So there's going to be some region above 1 that we have to shade in, and it's going to end at some number z naught. Okay, so we have to find that number. And this one's relatively tricky, but if we remember from the last video, because again, everything has to be based around 0, so how the heck do we figure out, how do we reverse engineer something that is from 0 to z naught? Ultimately, we need to get 0 to z naught from somewhere. Well, the nice thing is, if you remember from the last video, whenever we had a picture like this where there's a big gap in the middle, you could model it like this. So the probability that 1 is less than z is less than z naught. Well, this was equal to the probability that 0 is less than z naught, right? It's everything from here up to z naught, minus just that little region that we don't care about. All right, just the little region we don't care about. So minus the probability that 0 is less than z is less than 1. Okay, now we have to kind of combine things. So we have to use a little bit of our reverse engineering skill and a little bit of our a little bit of what we know and a little bit of this new skill that we've learned in the last few questions. So I know what the value of this number is. It's certainly 0.0686. So I'm just substituting that number in for this whole expression right here. We don't know what this is yet, but we're going to figure it out. And the neat thing is, too, we know what this is. In fact, we can use the table to figure that out using the standard method that we learned last time. We need to find the probability that z is between 0 and 1. Well, you know, it's a 0 and 1 problem, so we can just look at the z score and say, well, there's 1, there's 0, 0, 0.3413. So that's minus 0.3413. And I just changed the color from here to here just so that it's a little cleaner. Now, we can use a little bit of algebra, because ultimately what we need is we need to have a value, a probability value for that expression, and that probability value is going to let us work backwards like we did here and here to get a value for z naught. So conveniently enough, we can add 3413 to both sides, 0.3413, and this is going to give me, and I'm just going to, well, you know what, let's use our calculator and figure this out first. So 0.0686 plus 0.3413 is going to give me 0.4099 equals the probability that z is between z naught and 0. And then now we do the reverse engineering of our z naught. So we need to find 0.4099. 0.4099 right here. And this corresponds to a z naught of 1.3 and 1.34. So z naught equals 1.34. Okay, and that's just, again, I'm just going to repeat how I found that. I found 0.4099. There's a 1.3 right there, and then there's a 0.04 right there. I add those together, I get 1.34. Next up, we'll do question D on the same page. And now it's trying to figure out some of the same stuff that we figured out last time, but now z naught is less than 0. Okay, and this is equal to 0.4830. Okay. Now don't be confused by the fact that I'm going to put a negative in the positive side. I'm going to explain that in 1 second here. So, okay. So what we're trying to find out here is we have a z naught down here that's negative, right, less than 0. The z is less than 0, but then z naught's less than z, so z naught has to be less than 0. So here's my z, here's my 0. Now, this is already a negative number. So if I were to say convert everything to positive, let's say this is, you know, so because you agree from the stuff that we've done before, if you have a negative number, everything's symmetrical. So when you need to compute things, you just convert it to the positive, because our whole table here is based around positive numbers. Well, this would then be negative z naught. Well, it's not negative, it's actually positive. But it's because this is negative, this has to be positive, because, you know, a negative times a positive is, or sorry, negative times a negative is a positive. So what this is telling me is that the probability that 0 is less than z is less than z negative z naught happens to be equal to 0.4830. So let's figure out what negative z naught is, and then it'll be pretty easy to just change the sign to get our regular z naught is. Okay, so looking on the table, 4830 happens to be right here. This is 2.1 and 0.02. So negative z naught is equal to 2.1 2. Or in other words, z0 equals negative 2.12. That one was a little confusing just because the z0 itself was actually negative, but hopefully you watch this video a couple times and it'll make a bit more sense. All right, now let's say C. So for C, just give me a second here. I have a computer open beside me, so I have to just make sure I copy down the right question. So we're saying, okay, the probability z0, or that z is between z0 and negative 2.6 is equal to 0.0024. Okay? So in this situation, let's try to draw it out again. We're always trying to draw these things out. I repeat that all the time. We're saying, okay, here's 0. Here's negative. So z is less than, so it's more negative than negative 2.6. So negative 2.6 over here. And then z0 is even further negative from the rest of them. So z0's over here, and then we're finding that region in there. Well, again, we can make everything positive. All right, so this is the exact same thing as if I'm saying, here's positive 2.6, here's positive, or relatively, I put a negative sign in front of it, z0, which is actually positive. And we're saying that the probability that 2.6 is less than z is less than z0 equals 0.0024. And so then if we can figure out z0 over here, I'm sure this should have a negative sign in front of it, we can figure out this negative z0, then the z0, which is actually negative, we can figure out pretty easily. And we do it, once we get into this situation, it's identical to this situation because we have a number down here and we have a variable up here and it's equal to some probability. So it's the same process as before. So there's the probability of 2.6 is less than z, less than negative z0 is equal to the probability 0 is less than z is less than z0 minus the probability that 0 is less than z is less than 2.6. Okay, we can look, we know what this number is. This is 0.0024. And we happen to not know this yet, but we will get there. Less than z is less than z0. It gets a little harder to write as I get to the bottom of the page here, so just bear with my messy writing. And we can look this up because if we find 2.6 on the chart, 2.60, 0.4953. So this is 0.4953. We do that little step of algebra where we add in 0.4953. Add in 0.4953. What do we get here? You guys can see my light ring that helps me illuminate things in the up here. So 0.4953 plus 0.0024. And I'm getting 0.4977 is equal to P0 less than Z is less than Z. Sorry, there should have been a negative in front of here all along. All right, now let's take a look at the table. 0.4977, oh, I found that pretty quickly. 2.8 in the row, 0.04 in the column. So this means that negative Z0 is equal to 2.84, or in other words, Z0, because remember originally we started with a negative problem, I just converted to the positive and started working from there, is equal to negative 2. Hey class, hey class, just sitting down. So again, I made a bit of an error. My phone was kind of filled up with storage, and I recorded the whole question F. Like I did the whole thing actually. It's actually right here while the phone wasn't recording. Then I set it all up again, and I had another technical issue. And so I started doing the problem, and so it's right here, but I haven't finished it yet. So let me just walk you through what I've done. I set the problem up. I said, okay, well this is the problem as it was given. So this is sort of our starting point. And then I said, okay, well, we're trying to find the probability that Z is between this unknown value and 0.14. So I drew the graph, and we started with 0.14. I plotted 0.14 and I said, okay, well, Z has to be less than 0.14. So I started shading and I said, well, do I stop before the 0 line or not? Well, typically if this number right here is bigger than 0.1 and your number is like and this number right here, the top number, is a tiny number, you're gonna cross that line with your shading. So I used the black pen and I shaded in all the way up to this unknown value, and I just kind of just put it somewhere here, Z0. And then I said, okay, well, remember last time we had a problem like this where we crossed the 0 line. The way we figured it out was because of the fact that the standard normal distribution is based around a 0, so that the way that I look up probabilities is all based around a probability that something is from 0 up to some number, or 0 down to some number. We had to split it up into an addition, right? I added these two numbers together to get my final answer. Well, it works the same with working backwards. The way that you solve for the missing quantity, which is again going to be that trying to find that Z0, is writing down what you know. When what you know is this whole region here, the probability from Z0 up to 0.14 happens to be equal to the probability that Z is between 0 and 0.14, and the probability that Z is between Z0 and 0. So we write it down. Probably 0 and 14. This is going to be, well, we can actually look this one up, right? So this is what I wrote down. I wrote down this expression, and each of these corresponds to the colors that I've used here. Okay, so I knew, now what I was doing here was I wrote this down because I already knew that this probability was equal to this number. Now I don't know this, but I can look it up because this is just like our standard problem from last class, or not last class, but the last videos that I did. So let's take a look here. Where are we going here? So 0.14, so we find 0.1 and 4, that's 0.557. So I can write down this is equal to 0.557. I really juggle these pens around as I do this work. And then, lastly, we don't really know what this Z0 is, so we might as well just put this in here. But now that we have all these numbers and we just have one probability that's missing, we can actually use a little bit of algebra to solve. So this is actually, because the way that, this is addition and this is positive, then what I do is I can subtract off 0.557. Oh, sorry, it's 0.557. 0.0557. I'm just going to add that little 0 in there. Sorry if it's messy. Minus 0.0557. I'm just going to take out my trusty calculator. And we're going to take, okay, well, 0.2542 minus 0.0557, and this gives me 1985. Well, 0.1985, which is equal to the probability that Z0 is less than Z is less than 0. Now, it's tempting when you have a number to say, well, I'm done the problem. But we know we still have to find that Z0 value. And that's pretty easy because now that we have this, we have a region from 0 down to Z0. This happens to be the red region over here. I'm just using black because I'm going to get the final answer real soon. But we can look that up because, again, remember, our table is totally based on 0 up to some number or 0 down to some number. The only thing we have to remember is that Z0 is going to have to be a negative number. So 1985, and that is right here. I have it underlined because I've already done the problem. 0.52. So that means that Z0, so remember that's 0.52. So Z0 is equal to 0.52. Oh, I made a mistake. I forgot the negative. So make sure you don't forget that negative when you have a negative value. That's it for this problem. I'll continue to upload videos as soon as I'm free, okay? And hope you have a nice day. Bye-bye.